Hello, everybody. How are you? Okay, great. So if you hang on a second, I'd like to make one request, which is please mute your microphones. We're about to start, actually. And let me just adjust this very slightly. Great. Yes, so the way to interact, by the way, on tonight's session, just to let you know, I think that people have already figured this out. We have a system here, which is what we like to use for all of our online events, which is based on this chat relay. And so if you want to try talking into the system, it's actually quite simple. All you have to do is you just have to, inside the Zoom chat, select to send a message to chat relay. And if you do so, the messages will appear right here into this screen. I'll describe a little bit more of that as we go on. But since we are now all here, again, the request is please do not use your microphones. If you want to participate, just type a message to chat relay and you can come right here. We're really pleased to be able to run tonight's collaboration again with one of the most interesting competitions that we've come across. It's called Math Kangaroo. And we're also really, really happy today to have the president of Math Kangaroo USA with us, because this is an official collaboration. At this point, I'd like to turn this over to her so that she can make a few comments at the beginning, possibly introducing you to the wonderful competition which they run. Joanna, if you'd like to unmute and just start talking, you'll take over the screen.
Hello, everyone. Can you see me and hear me?
Yes, we can, Joanna. It's all perfect.
Okay, wonderful. I'm super excited today to have this event with Po-Shen and his team. I'm glad he found out about us and he proposed this collaboration. I'm really happy he thinks of our questions highly, that they are interesting. So what is Math Kangaroo? We have a broad audience here, and maybe some of you are from different countries. I want to tell you that Math Kangaroo is in 94 different countries throughout the world. And if you participate in the Zoom presentation today and you do not live in the United States, there's a high chance Math Kangaroo is also organized in your own country and in your own native language. Math Kangaroo is one round competition for all grades, from first grade all the way to the senior high school. It always takes place on the third Thursday in March. The name was taken from the Australian origin of the competition. And since the kangaroo is a well-known animal in Australia, its founders decided to name the competition after this cute animal. The questions are indeed interesting and thought-provoking, as they contain a lot of fascinating math, but also logic, spatial imagination, and creativity. The questions are unique because they are created by the teachers, professors, educators from these 94 countries. So they may have different backgrounds, different stories, different topics. Once a year, the Math Kangaroo representatives meet in one of the participating countries, and out of the pool of hundreds of questions that are gathered before this meeting, they choose the best 24 questions for grades 3, 4, 1, and 2, and also 30 questions for grades 5 to 12. What you will see here today is some of the problems from this year's competition, 2022, that were chosen for grade 7 and 8. But I will ask Po-Shen to talk a little bit about it and discuss it with his team. Today, I also wanted to invite you, all the students here that have never participated or maybe never heard about this competition, to participate in this fun event. All participating students receive gifts, and winners are awarded with items like gold medals, math camps, cash scholarships, and more. Registration opens in September, but your regular school or after-school educational institution may sign up even now to host this competition. So if you're a teacher here and you would like to have your own team of smart students to participate, please contact us anytime between now and late summer. Our next competition is in March of next year, 2023. An important thing I want to tell you also is it's not selective competition. You don't have to pass a certain test to qualify, but anyone can participate. And now, without any further ado, let me invite Po-Shen to take it from here. Hi, Po-Shen.
Hello, hello. Great. Well, thank you very much, Joanna, for making that introduction. We're always very happy to be able to do these kinds of official collaborations with amazing competitions. And thanks for sharing with us all that history. For all of you in the audience, I hope that you found that interesting as well, because actually when I was doing these contests before, I also wasn't quite clear why they were called what they were or what their philosophies were. Now that we are doing a lot of things on the educational side, we like to think about what all of those are. And again, as you can see, the chat system is working again. It depends on who is the one who's presenting. We just happen to be using this system regularly. A couple of us who are always teaching in this fair using the system regularly. So yes, the chat system is working again. Now, I'd like to say a little bit about who you're going to meet tonight. So I'll be doing some of the questions, but you didn't come here only to watch me do the questions, because actually there's some very remarkable other people who are also on here as my co-hosts. I'd like to say a little bit about them. I have Aiden here and Megan. And Aiden and Megan both have very strong mathematical backgrounds. In fact, they both participated in many math competitions, including in the US, many people do something called Math Counts. And in fact, both of them qualified for the National Math Counts competition from their states. One was from Texas, one was from Nevada. And so what we have here are people who have done a lot of math contests before. And so we're all brave enough to try to solve these questions without having seen them before. Now, let's go right ahead. For this, maybe actually just so that each of our co-hosts can appear on camera a little bit, why don't you each take turns saying hello, maybe by alphabetical order by first name, just say hello, just so that everyone can see what you look like.
Awesome. Hello, everyone. I'm Aiden.
Hi, I am Megan. If this will show up, yes, it will. Hi. And I want to second what Joanna said. I have so many cool stuff from Math Kangaroo that I've just gotten randomly, and I want to show it off at the end, so stick around.
Amazing, amazing. Yes, so we are also fans of Math Kangaroo. So with that, we're going to just dive right ahead and do the questions. And again, let me just adjust my chat here so that it doesn't block the questions. Again, I want to emphasize the reason why this live solve is so interesting is because of the qualifications of the co-hosts who are with me here. It's amazing to be able to work with people who are this sharp. All right, so now let's see. Let's do some questions. And by the way, if you're watching this from YouTube or from Facebook or from LinkedIn or any of those, you can actually all come and you can join the Zoom meeting if you want. I put the link in all of those. Or if you use the chat link that we provided for all those platforms, if you chat through that special link, your messages also have a chance of coming here. Actually, at this point, I want to describe how the system works. You see, there are so many people who are so energetic and talking about the problems that we actually can't put every message that appears here. So the way it works is actually every second, at most one message makes it through. Which one? Well, it's a bit of a random luck. Which one is randomly picked, except that some people are more random than others. Well, what I mean by that is that there's a reputation involved here. If you make good comments, the moderators will like your comments a lot. They might even give you a star or a couple of stars. When that happens, your comment definitely appears. So if you make good comments, they tend to appear. And you also then increase your reputation, which increases the chance that future comments you make appear here. And unfortunately, if you make disruptive comments or things that aren't so pleasant, you unfortunately get your comment moderated out. You get some negative score. And what that does is it reduces the chance that your message will appear in the future all the way until you get muted. So that's just a thing to be aware of. And that's how this system works. All right. Well, with that said, let's go ahead and dive into these questions. I haven't looked at them myself either. So this is the first time I'm thinking about this. Okay. Right. Kangaroo enjoys jumping on the number line. I guess this is a Math Kangaroo. He always makes 2 large jumps followed by 3 small jumps as shown, and then repeats the process over and over again. Kangaroo starts his jumping routine on a 0. Which of these numbers will Kangaroo land on during his routine? Oh, okay. So it looks like there's going to be a +3 and a +3, and then +1, +1, +1. That's convenient. The thing I'm thinking about when I look at this is that means that after one of these bits of the routine, Kangaroo has moved by 9. And that means that everything is going to repeat modulo 9. That means you look at what the remainder is when I divide by 9. So for example, when I look at whether or not the Kangaroo person, or not a person, the kangaroo will get to 10, that's the same as asking, will Kangaroo get to 1? Because every 9 is the same unit. So let's see. So now if I have these numbers 82, 83, 84, let's convert all of them to the remainders that I would have if I divided by 9. So 82 is 1. Well, Kangoo doesn't get to 1, so that's not it. 83, the remainder is 2. Kangoo doesn't get to 2 either. 84, the remainder is 3. That looks promising because Kangoo can get to 3. 85 is remainder of 4. Nope, Kangoo doesn't get to 4. And 86 is a remainder of 5. And nope, Kangoo doesn't get to 5 either. So it looks like the answer, I think the answer is just going to be C84. Let's see if that's right. Yes, it is. Okay. Do my co-hosts have anything to add on this?
This is probably needlessly complicated for this question, but we can also look at the answer choices. See that we have 5 consecutive numbers, and notice that the way this is set up, the only area where we can have 5 consecutive numbers where only one of them he lands on is when they represent spots 1, 2, 3, 4, and 5 in this picture, which means the answer must be our middle option.
That's amazing. Okay, this is why it's important to bring brilliant co-hosts. So you're saying I didn't even need to do the division and look at the remainders. That's great.
Yeah, there are many ways to solve this question, and just choose the one that works best for you.
Cool. This is amazing. Okay, well, in that case, let's continue going on. Let's just go in alphabetical order by first name. That's the easiest way for us to keep in order. So I guess Aiden, how about you?
All right. Okay, so in this question, we have Rob the builder. He has a brick whose shortest side is 4 centimeters. He uses several such bricks to build the cube shown. What are the dimensions in centimeters of his brick? Okay, so let's see. The information we have here is that he has a brick whose shortest side is 4 centimeters. And then he uses several of them to build as shown. So let's take a look at his brick. I will draw that real quick. The shortest side is probably going to be this side. So that would be 4 centimeters. Now, if we look at the edges here, let's take a look. This side, there are 1, 2, 3, 4, 5, 6 short sides. And this side, there's some more sides. Okay, so what can we do from here? We have our piece of information. How do we start to attack this brick? Every block is 2 centimeters long, 24 centimeters length. It is a cube. All right. So actually, let's see. It is a cube. All right, so we know this is a cube. Now, how can we move on from here? Since it is a cube and we know one of the dimensions, we can figure it out from there. It's the first shortcut is to look at the top. Okay, let's look at the top. We have 6 rectangles here. And what else do we know about the rectangles?
Well, wait, Aiden, did we ever establish what the side length of this cube is? Because I think that might help us out a bit here.
Awesome. Okay, yeah, let's take a look at that. What is the side length of this cube? Side length of this cube, 4 times 6, which is 24. Perfect. So if we look at our rectangle again, we know that this side is 4, so these shortest lengths are also 4. And since there's 6, the side length should be 24. And now we have the basics to solve the rest of the problem. If we take a look here, there are actually 3 rectangles here, so each of the side lengths there should be 8. Or actually, yeah, it should be 8. 24 divided by 3 is equal to 8. And then finally, we have one more long side here. If we take a look, that's 2 rectangles. So 24 divided by 2, that gives us 12. And there we have it. Those are the 3 sides. And so I think the answer is C. And let's see if it's correct. Okay, indeed it is.
Yay. Good job. So I think it's time to go on to the next question.
Yeah,
Oh,
nice.
this is cool. Yeah. There are 5 big trees and 3 paths in a park. In what region of the park should a new tree be planted so that for each path there are the same number of trees on both sides? Okay. Well, I think what I want to do is I want to just look at each path and see which side of the path it needs to go on. So first up is going to be our vertical path. So that's going to be this one right. Yeah, can't exacto. The vertical one that splits A and B from C, D, and E. That one has 2 trees to its left and 3 to its right. So that means that we need it to go in either A or B. So that's some great news already. And actually, A and B are split by one of the 2 horizontal paths. So we can just ignore the one that splits off E from the rest of them, and we can only focus on that other one, the one that splits B, C, and E from A and D. So what do we do now? Well, we see that there are 3 trees below that line and 2 above it. Hence, like you guys are saying, we are going to put our tree above in the section B. And yeah. So that is some great explanations coming in from you guys also. And we can go and check our answer. Ah, option B, which is B.
Yay.
Yeah.
Cool. Yeah, that's a neat question. It seems like the challenge there is to understand what it's asking and then to reason logically. That's actually one of the reasons I really like these Math Kangaroo questions. They're not like all standard. Okay, let's go on. And by the way, the reason I don't really like standard questions is because some people go through math just practicing how to do standard questions. And then actually those of us who make competitions are always loving to ask questions to see if anyone can actually think. And when I first saw the questions Math Kangaroo was asking, I said, my gosh, I have to think about these. I haven't seen them all before. This is good. This is a good contest. Let's see. All right, next question. 3 sisters whose average age is 10 all have different ages. When they get together in pairs, the average ages of 2 such pairs are 11 and 12. What is the age of the eldest sister? Okay. Speaking of question types that you see a lot, sometimes it's like, oh yeah, you have 2 things add to something, the other 2 add to something, the third 2 add to something. But that's not what this is. So this looks like a standard question, but it's not. Instead, I need to actually understand what's going on. So I have 3 sisters, and the sisters we should just call A, B, and C, because that's how we name people in math. So they're called A, B, and C, and those are the ages. So I'm going to try to write this down this way. I have 3 sisters, A, B, and C, and the average age of 2 such pairs is 11 and 12. So you can think of that as A plus B over 2 is 11, and B plus C over 2 is 12. Okay, and now immediately I don't like fractions, so let me multiply out the denominator, and I'll get that tells me that A plus B is 22, and B plus C is equal to 24. Okay. Oh, and the average age of all 3 of them is 10. And I'm actually not claiming yet whether A, B, or C is the youngest, middle, or the oldest sister. We'll find out at the end. But if all 3 together, the average age is 10, well, that would be the last equation is A plus B plus C divided by 3 equals 10, which gives me that A plus B plus C is 30. So A plus B plus C is 30. Now let's use our wits and attempt to solve this. Well, this is nice because if I know that all 3 add up to 30 and 2 of them add up to 22, I can use that to figure out what C is. What's C, everyone? You can just type it into the chat. A plus B is 22. The sum is 30. I see people typing this into the chat. Just subtract 30 minus 22 and get 8. So between these 2, I get that C equals 8. Now, can anyone tell me what happens if I take these together? So I know that B plus C is 24 and A plus B plus C is 30. So you now know that I guess it's A which is missing. A equals 6. Good, the chat's fun. You guys are writing the answers. A equals 6. And I guess I need to put everything together. My gosh, the third person is quite old compared to the other two. So I have A is 6, B is 8. No, A is 6, C is 8. So if I add these together, I get 14. And that leaves 16. We got a 16-year-old. So I think that B is equal to 16, because that's the only way to make them all add up to 30. So that's telling me E, which I see a lot of people in the chat also telling me E, because you see, I didn't know which was the oldest until I actually got these numbers. Is the answer really E? Yes, it is. Okay. Co-hosts, do you have any things you want to add?
I just want to draw attention to one comment I saw in the chat that said making math easy by turning it into like numbers and equations. I think it brings up a really good point that a lot of these questions aren't about whether or not you know what the integral of x cubed is, because that's just not the point. It's about how you can take what it is, what the problem is stated, know what you need to do with it, and then use a relatively simple amount of actual mathematics, i.e. the numbers and equations. That's the simple part. And once you get that, then you're all good to go.
Yeah, I agree with Megan. Math is sort of like a different language. You can translate the problem into math, and then you know what to do from there. Awesome. Let's go to the next question then. So in this question, in my office, there are 2 clocks. One clock gains 1 minute every hour, and the other loses 2 minutes every hour. So some inaccurate clocks. Yesterday, I set them both to the correct time, but when I looked at them today, I saw the time shown on one was 11. That's going to be important. And shown on the other is 12 o'clock noon, so 12 p.m. What time was it when I set the 2 clocks? And then we got a bunch of times. So the first thing I noticed when I saw this question is that 11 and 12 are exactly 60 minutes apart. And maybe we can use that somehow. So if we look at our earlier information, one clock gains 1 minute every hour, and the other loses 2 minutes every hour. Because I know the difference of the clocks at the end of a scenario, it'd be nice if we can know the difference of the clocks every hour. So we can actually rewrite these conditions as they become off by 3 minutes every 1 hour. So this is classic now. It's off by 60 minutes at the end, and the rate is off by 3 minutes every hour. So we know that means 60 divided by 3, 20 hours passed since we put the clocks at the same time. And however, we cannot just subtract 20, because which one of these will we subtract them from? Actually, the answer is none, because both of them are inaccurate. We need a way to find the correct answer, the correct time. So we can go back to our question, loses 2 minutes every hour and gains 1 minute every hour, to see that the clock that's losing time, which is the 11 a.m. clock, is twice as fast as losing time as the 12 o'clock is at gaining time. So we know actually that's a 1-to-2 ratio. We could split it into 3. So the correct time right now is 11:40. And now all I have to do is subtract 20 hours from this. And we can do that by adding 12 hours to the 11 to get technically 23:40, and then conveniently subtract 20 hours, we get 3:40. And so that would be answer choice C, 3:40 p.m. Okay, so is this correct? Perfect.
And one thing I want to point out is that you could confuse which one gains time and which one loses time, right? And you could end up getting an answer of like 3:20 p.m., right? But 3:20 p.m. isn't an answer choice. So as long as we're confident that it's 20 hours before, sometime between 11 and 12, we know that it's going to be between 3 p.m. and 4 p.m. So we can use that as a little safety net to check our math, which I think makes this question really nice.
Yeah, using the answer choices is a pretty good test taking strat. I actually got the idea of splitting into 1 and 2, 1/3, because I saw the 40s and the 20s in the answer choices. So I knew there's going to be something about 1/3 in this question.
Definitely. Okay, what's our next question looking like? So looks like it's this question number 17. So we're going to place the numbers 1 through 8 once each on the circles, and then use the numbers shown as the products, and we want the sum of the numbers in the circles at the bottom of the figure. Okay, let's do this. That is a very small diagram on my side, so let's make our own where we can fill it in at our leisure without covering you guys. That would be nice, wouldn't it? So, lovely diagram here. Now, what I first notice is this one right here. The products of 105 and, yes, you should mute, 25, the products of 105 and 28 both have a factor of 7 in them. 7 times 15 and 7 times 4. And so what that means is that we need a 7 in this spot right here. So we can go ahead and write that down. And the next thing I want to look at are these two numbers, this one right here and this one right here. I said earlier that 28 is 7 times 4. I need to find out how to make 4 out of the numbers 1 through 8, not including 7, without repeating anything. So, yeah, like you're saying in chat, 1 and 4 are going to be our options. So, I don't know yet which of these No, I do know which of these is going to be 1 and which is going to be 4, because 4 isn't in 30. So this one can't be 4. So what we have instead is that this one is 1 and this one is 4. And, okay, yes. So that's some good progress already done. We can go back to 105, like Alina is saying, that is 3 times 5 times 7. So the question is now just which of those is going to be 3 and which is 5. Now, there is no factor of 5 in 144, which means that we have to have this one as 3 and this one as 5. Yeah, and so that leaves 6 for right here, and the only numbers I haven't used yet are 2 and 8. I could check and see which order they go in. I think that we have 2 is the one that goes here, 8's the one over there, but honestly it doesn't matter. I just need to add 2, 8, and 7 to get an answer of 17, or D, just like you guys are saying. So yeah, awesome job. Now we can go check that. Yes.
Yes, that's amazing. This is a fun question.
Definitely.
Cool. Yeah, these kinds of questions all involve like this creative thinking. And so that was neat. I see other people like that question too. Aiden, did you have anything you wanted to add here? I was just going to say that I thought that was pretty good.
Yeah, I thought so too. Sometimes in questions like these, you just gotta go through each square, think, and then get some sort of answer. It'll be cool.
Great. And of course, it's also useful to be able to factorize these kinds of numbers. So that's good. Let's see, what's next? Oh, more puzzles. They're all puzzles. Okay. So Jenny decided to enter numbers into the cells. Let me make this a little bit bigger so it's easier for me just to straight up read. Jenny decided to enter numbers into the cells of a 3x3 table so that the sum of the numbers in all 4 possible 2x2 squares would be the same. The numbers in 3 of the corner cells have already been written as shown. Which number should she write in the 4th corner cell? Interesting. So now it's telling me, so it's telling me that I don't have any restriction on the numbers being from 1 to 9 either. So now I have to think about this. And I guess I'm just going to look at what happens if I have all of the sums being the same. Oh, here's something neat. Let me see. Usually there's a picture on the next screen. Very good. So what I'm going to say here is if I added these 4 numbers together, that's supposed to be the same thing as adding those 4 numbers together. Okay, but you see there's an overlap here. Do you see how this is? So if I have these 4 added together, the green things, that's the same sum as these 4 added together, the blue things. Well, in that case, then these 2 added together equals those 2 added together. Effectively, what is going on here is if I ever had something like A plus B plus C plus D equals to C plus D plus E plus F, then you can cancel out the common parts and get that A plus B and E plus F are the same. Well, with this, now I know that the sum of these 2 is equal to the sum of those 2. Everyone okay with that? So these 2 sums are the same. All right. Now I'm thinking about how I could try to make these things overlap. Let's start giving these some names, because I actually want to find some pattern about how all these numbers add together, and I don't care whether they're called 2, 4, 3, or anything. So I'm going to clear this off, and I'm going to write down, I'm just going to try to draw and see if I can find something interesting. The numbers are A, B, C, D, E, F, G, H, and I. And because of the thing I just noticed, I know that, for example, A plus D equals C plus F. But I can do this where I don't just use those 2. I could also, for example, use these 2. Is that what I want to do? We'll find out. Maybe I can try these 2. So if I do these 2, I get D plus G and F plus I are the same. I'll write them the other way though. I'll write D plus G over here equals F plus I. Why did I do that? I'm not entirely sure, but I did that because I was wondering if I add these equations together, I might get some cancellation because I see a D here and I see a D there. So what I'm just trying, right? And I just said because these 2 added together is the same as those 2 added together. Now let's add these 2 equations together. Add these 2 equations together, and I get A plus D plus F plus I is equal to C plus F plus D plus G. There's some canceling that's going to happen because now I see there's a D on both sides and there's an F on both sides. Is this useful? Now I know that A plus I is equal to C plus G. Let's see. What are those? Wrong. I wanted the eraser. Okay. So what are those? Those tell me that if I took together the A plus I, which is, oh, this is cool. The sum of the 2 green things, which is the opposite corners, these 2 add up to the same as the C plus G, which is those 2. I think we can solve the problem now. So 2 plus 3 is supposed to be the same as 4 plus 1. They both add to 5. I see all of the people posting in the chat. So this thing must be 1. So I've just figured out that this thing here must be 1. And you can see how I was doing this. I wasn't writing all of the equations. I was just trying to figure out ways that I can cancel things against each other. Because I know that the sum of 4 things equals the sum of 4 things. I don't want 8 variables. So I want to find ways to get overlaps. So if I get the overlaps, then I only have sum of 2 things equals sum of 2 things. And so if I go back here, I'm going to say that I think the answer is going to be 1. Let's double check the answer and then talk a bit about the questions that are coming up. So I think the answer is 1. It is. And now the deep question people have asked is, can you figure out the other numbers? Oh, here's something neat. I'm just thinking about this now. I bet that in here you can write anything you want. Do you know why? I see other people are saying this already. The middle doesn't matter. The reason the middle doesn't matter is because if you take 4 numbers, then like those 4 numbers that make a square, they all include the middle number. So actually, I guess we could have made it simpler. The condition just tells me the sum of any 3 like this is equal. So I've got these 3 equals those 3 equals those 3, and so on. That's interesting. So we already know there are infinitely many possible solutions. And apart from that, we have some conditions on these added together. And actually what I have here is I actually have, what is it? This equals this, that's one equation. This equals this is another equation. This equals this is another equation. So I have 3 equations basically. And I'll have 3 equations, and actually it's 8 unknowns. So something's telling me there should be something called 5 degrees of freedom. This is more advanced than what we need to do in grades 7 and 8. This is related to linear algebra. But I'd say that would be a longer Ask Math Anything. We'll leave it right here as saying the answer is 1, and there are infinitely many ways to fill out this board. Do my co-hosts have anything they want to add?
This is just a hunch, but my intuition is saying if we let me pull back up that. If we increase both the top and bottom, or both the left and right middle ones by a constant, that will give us the same answer. So they'll have a constant difference between each of those 2 pairs, but we have infinite for those 2 also.
Yeah, I wanted to talk about a little bit of the problem-solving strategy here. Basically, what we did in the beginning was we explored a little, and then we jumped right into setting 9 variables. So I'm sure we've all been taught that if you got 9 variables and not many equations, then you're going to get infinitely many solutions, which is bad. But in this case, that was not bad. So always try new things, even if you don't think they're going to work. There are a lot of problems like that. Anyways, so let's get into the next question. What is the smallest number of cells that need to be colored in a 5x5 square so that any 1x4 or 4x1 rectangle lying inside the square has at least 1 cell colored? Okay, so what we're trying to do here is color cells so that we can choose a 1x4 and a 4x1 rectangle such that they all have at least 1 cell colored. In these types of questions, what I like to think about is we don't want to waste any. So what I mean by that is we don't want a lot of 4x1 rectangles that have 2 cells colored, because then we're almost wasting a few cells. So let's jump into it, and let's try not to waste anything. So I'll just color this corner cell first. And then we got this 1x4 rectangle. This is all good. And then this 1x4 rectangle, that's all good. So we don't really want any more colored cells in this 1x4 or this 1x4, or else it's almost as if we're wasting a cell. So next thing I see is if we put something colored here, then we're going to overlap more of these squares, and that's bad because we've already colored them. So instead, I'm going to color this cell. And then this one's covered. And then we also got the entire upper row covered. As well as going down here. Yes.
If we put a 1x4, so that is a vertical one, topmost, leftmost, wouldn't that not be covered by either of the 2 that you just drew?
Oh, yes. Okay. Yeah, so actually, I did worse than waste. I didn't put enough. Let's see. Let's try that now. Actually, that brings me to a better idea. Instead, what if we just color this middle one right here? That way, we got the entire column covered. All right, let's see. And then, so we got this entire column covered, but then this middle row, we're going to have to put something right here again. So now we got the row and the 2 columns covered. So let's see what we want to do next. If we try, Actually, let's make an observation before we actually start doing a lot of things. My observation right now is that there are 5 rows and 5 columns. So there's going to have to be at least one colored cell in each row and each column. So that's sort of like a chessboard. You got to put a rook in each row and each column so that the rook is attacking all the squares. Let's think along those lines now. So if we wanted to just try something random, every column, every row, in this configuration. So right here, we have almost all of the cells, almost all the rows, almost all the columns covered. But if we take a look at this column or this row, not all the 1x4 or this row actually, for that matter, not all of them are colored yet. So we know we're going to have to add more. Let's see. What if we added this colored cell? And then we'd have to add another one. So that brings my lowest right now to 7. But I'm not done yet because there might be better ways to color the cells. Let's keep trying. So our goal again is to not waste any or to not underdo anything either. So diagonal, please. Let's see. What if, yeah, if we do the diagonal, then we'll have to put something here, and that's 7 again. What if we try something different? Let's put our first one here, and what if we put our second one here, and then we know the second column is going to have another one need to be placed in it. So let's try to avoid the edges. But we know there's definitely going to be 2 edges, top and bottom, and then 2 edges in the columns. So if we could fix those with 1, my mind is going towards 6. If we can make 6, then that's good enough. But let's see if we can still do that. So what if, let's try putting something in the middle. And then we go down, and then we go up possibly. And we can go here maybe. And how about here? In this case, we have 5 now. If we can solve it with 1, we're good. But I don't think we can solve it with 1 here because we got here and here and here, which don't align. Megan, do you have any ideas?
Yeah, I think that 7 might actually be our minimum. And so here's my basic reasoning why. So if we take our lovely grid right here, then so we know that we'll always have one that's leftmost, one that's bottommost, one that's topmost, and one that's rightmost. And in order for our 5 to cover every row and column, there can't be any overlap between these. And if they don't have 1 per row, 1 per column, then we'll need an extra to fill that in anyways. So we'll go over 7 already.
Wait, I'm a little bit, I just want to interrupt. I'm a little bit curious. I'm wondering if I'm misunderstanding the question because I think I can do it with 6.
Huh.
Does this
Oh,
work?
wow. Yeah, that looks like a working configuration to me.
So by the way, I will say that you, Aiden, trying to solve this question on the spot is significantly harder than me just kind of watching and being like, I wonder if I can do this. So by the way, I want to make sure I'm not misunderstanding something, but when I read the question, I was like, this reminds me of Battleship. Does anyone know what I'm talking about? There's this game where you like say H4 and it's like hit or miss, and then there's like this ship you're trying to hit, and sometimes you're trying to capture that last little ship. The aircraft carrier is the easiest one, the 5 across, and then at some point there's this like tiny little ship. It's really funny in that game. The hardest thing to win is to knock out the tiny little ship. It's the exact opposite of a real war, obviously. But anyway, so the deal here is that if you're trying to do Battleship, I just remember when I was a kid trying to play Battleship, I was like, well, I need to find that thing. I'm going to go diagonally sweeping down like this. So I think this is actually how you can do it with 4, because this actually gets it with 4. And this is using a lot of the ideas that people had, like Aiden and Megan had. And by the way, this makes it easier because then I only have to prove why 5 doesn't work.
Oh, that's easy to do.
That was also the bit of my intuition. It was like, this is a middle school Math Kangaroo question. So if you have to prove that 6 doesn't work, that sounds like a hard proof. But proving that 5 doesn't work, I know how to prove 5 doesn't work. The way you can prove 5 doesn't work is exactly what Aiden said. Aiden said, and maybe Megan said the same thing too, but it was that every row and column, you better have something, right? So the deal is like, you must color one, at least one, not just one, at least one per row and column, or else that pesky ship is going to be able to hide in that row or that column. Okay, well, could you do it with 5? Well, if you did it with 5 and if there's 5 and there's at least 1 per row and column, do you know what has to be true? If I used 5 things, if I colored exactly 5, and I require that every row and column has at least 1, now you know that it's very tight. These two things together, this is the proof part. These two things together tell you that you must have, if it was possible to do 5, you must have exactly 1 in each row and column. Okay, well, if there's exactly 1 in each row and column, here, this row, there's exactly 1 in this row. Exactly. So now if there's exactly 1 in this row, I don't know where it is. It's somewhere. Maybe it's this one. I'm just randomly marking 1. It doesn't matter which one I mark, because once I mark that one, the fact that there's exactly 1 in each row and each column, there's already the 1 here. So the whole column, the rest of the column is empty. So that's going to force me that all of this part is empty, because exactly 1 per column. So that's actually a proof. That's a proof of why 5 is not possible. Because the thing is that if it was possible to do with 5, well, you have to have at least 1 per row and column. Then there has to be exactly 1 per row and column. Go grab the top row. There's something there. Whatever is there, the rest of that column, there's exactly 1 thing. So the rest is empty. There's that 4-item thing. I think it's called a cruiser, which you missed. And so I think that's the proof of why 5 is not possible.
Yeah.
That's amazing.
Okay.
Now all of y'all can go home and play Battleship.
Yeah, I think Professor Lowe's thinking is really cool, because the logic I was going with is that we place down our 5 that cover this, but then we can't have, with the 1 additional one, cover all of the 4 spots here where we can have a 4. But what Professor Lowe is doing is he's using the original 5 to help prevent some of those already. And so he's making more efficient use of it and thinking a little bit more outside of the box, which is a great thing to remember always.
Again, I had the luxury of not being on camera, so I was just like, how do I play Battleship here? Well, Aiden's struggling, but I mean, it's not. I'm just saying it's significantly harder to do this when you're on the camera. So, cool. Anyway, I'll be quiet now. Let's keep going.
Yes. Am I up next? I honestly do not know.
Yeah, go for it, Megan.
Awesome. Okay. Several points were marked on a line. Renard then marked another point between each pair of adjacent points on the line. He repeated this process a further 3 times. There are now 225 points marked on the line. How many points were there initially? So the first thing that I want to think of is, if I start with n points, how many points do I have after 1 iteration of this? Well, I mark a point between each pair of adjacent points. And so there are going to be n minus 1 of those. So that means that we add n minus 1 points. Or, in other words, we've doubled it and subtracted 1. Now, this is a very easy algorithm to reverse now, because I start with 225, I add 1, and then I half it. Okay, it works a bit better when you half it correctly. And so this is, we know that he has done it 4 total times, and that, so this is what happens after he's done it the 4th time. This is it after the 3rd time. Okay, let's do this again. Add 1, 1, 1, 4, half it, that is, I'll move up here, 57. And that's after 2. Add 1, 58, half it, 19. After 1, add 1, 10, half it, 5. Which is not an answer choice.
I think your 58 might be the thing. When you have 58.
Oh, yep. That would be an issue. Because half of 58 is actually 29. Add 1, 30, then 15. Which is an option. Yeah. Oh yeah, and someone's saying he only did it 3 times, but it actually says he did it a further 3 times. So he did it 1 time and then 3 more, which makes for a total of 4. Also, notably, we arrived at something which is an answer, which always helps. It's not good if you arrive at something like 5, which isn't an answer. And also, a good way to make sure I did this correctly is at no point was I unable to get an integer out of this. If any of these I tried to have an odd number after I added 1, I would be in a bit of trouble, and I know I probably messed up somewhere. But I didn't, until I did, but that's a different story.
Man, I will say I misread the question, by the way. I was only going to do it 3 times. But Math Kangaroo...
Well, you see, that would be incorrect.
Yeah, but Math Kangaroo was nice to us because 29 was not an answer choice. If 29 was an answer choice, I'd have gone for the 29 and I'd have been done. So, okay. Is this the last one? I don't know. Let's find out. Oh, no. Oh, this is the last one, number 30. This is going to be the hardest one. So if my co-hosts see any ideas, just feel free to chat in, okay? So I'm going to attempt to do this, but we'll just all play. There are 2022 kangaroos and some koalas living across 7 parks. In each park, the number of kangaroos is equal to the total number of koalas in all the other parks. What? How many koalas live in the 7 parks in total? Okay. So we have not just 7 variables, we have 14 variables, right? Because there's 7 parks and there's kangaroos and koalas in the parks. Okay. I don't feel like writing 7 letters, so I'm going to try to draw a little diagram, and I wonder if the diagram is going to help me at all. It may or may not. 7 parks. So my diagram is going to be that there's this 7 rows. Wow, this is super hard. How do you cut something that's 7? Maybe that's right. So I have 7 rows. Okay, I've got 7 rows, and the way these are is that, oh, they both start with K. I don't even know how to draw kangaroos and koalas, but like kangaroos. This is my kangaroo. That's terrible. And what's my koala? My koala has, this is a koala, okay? So I apologize for the oh, yes. Megan, what did you want to say?
I think I solved it.
You solved it. Okay, go, Megan. You got it.
I think I solved it. Yes. Okay. So I know Professor Lowe does not like the writing all the variables. I don't either. I wrote out 4. And the reason that I want to do that is because mathematicians like to imply patterns a lot, and I'm going to take full advantage of that. So I said, well, how many kangaroos are at Park 1? Well, that's the total number of koalas minus all of the koalas at the other parks. So if we were doing this with different variables, that would be like B, C, D, E, F, and G. And then the same goes for each of the other 7 parks, except for that they alternate which one they subtract, which means when we sum together all of the kangaroos, which we want to do anyways, we know how many kangaroos there are, we have 7 counts of the total number of koalas and a combined 6 counts individually of the koalas at each park, which combines to 6 counts of the total number of koalas. 7 minus 6 is 1. And so that tells us that the total number of koalas is the total number of kangaroos. And I didn't even write out too many variables, so I'll count that as a win.
Hang on, did you say they're equal though? Like the answer is equal? That doesn't feel completely right to me.
Really?
Because somehow I feel like there's something, the ratio is like the kangaroos is equal to total number of koalas in the other parks. So it feels to me like there's more kangaroos than koalas. There should be a lot more kangaroos than koalas, but I think your logic is completely right. I think
You know
you probably
what?
need to divide by something. I think your logic is excellent, but we just probably need to divide by something.
You know what I think I did? I bet you the answer is in this k tot, then the total number of koalas minus. We don't actually need that because that just gives us a number of koalas there. We want the number of kangaroos there.
Mm-hmm. Yeah. So I mean, I was listening to you talk, and I was like, oh yes, I'm getting overly complicated. I still didn't draw any. I didn't draw any variables yet, but somehow it seems like you're doing like a 6 times counting. That's what it feels like to me, because I'm like, whatever is the number of kangaroos in here, that's a park. Number of kangaroos in this particular park, that's the third park in my diagram. That's equal to the total number of koalas in all of the other parks. That's equal to all of these added together. But then what, Megan, you're doing is you're trying to say just add up these equations, add up 7 equations. And if you add up 7 equations, what did I just find out? I found out that this one thing here is equal to the sum of 6 of those there. And if I add it up over all of these, I think I'm going to get that the sum of all of these is going to cover everything else 6 times. Is that right? I think what I'm getting is that the total kangaroos is equal to 6 times, let's draw a better 6 times total koalas. Do you agree with that?
Yeah, I definitely agree.
Okay, now is the hard part. Anyone good at division?
We can divide by 2 first. That's easy enough.
Oh yes, I like that. Now what? I actually have to do division. It starts with a 3.
And then how do you math? 21, 7. So 33, 7.
Oh, 33, 7. Okay, excellent. I actually just said it starts with a 3, so it's going to be answer B. But yeah, I see some people have just made a comment. These geniuses don't know how to divide. Apologies. Yes. Thanks for the answer, Tracy.
We have calculators for that.
Yes, that's right.
Either that or we have a coach who just tells us you need to memorize the prime factorization of the year, and no one told me that this year, so I never did it.
Oh, it's the prime factorization of the year.
Yeah.
Is 337 prime?
Yeah.
Oh wow, I didn't do that.
Is it? No, it's not. No, it's not.
What does it break into?
It? I don't know, but it's 4 less than 2025, so it can't be prime.
Some people in the chat are claiming it is prime. I'm just like, I haven't seen it.
It's not prime.
Okay, cool. Well, with that, unfortunately, we're actually out of questions. I guess that was question 30, but we're also almost out of time. So
wait, no, it is prime. Shoot.
It is prime. Well, hey, now we all know you'll do math competitions for the rest of the year. You got half a year left to use this. Oh, almost exactly half a year left to do this. And if you're in Australia at this point, it's even July 1st, isn't it? So we're right smack in the middle of the year. That's fun. Well, we've got like a minute left or so. I just want to toss the floor back over to the president of Math Kangaroo USA, who we're working with to run this live solve. Did you want to make any comments, any closing remarks, Joanna? You can just unmute and you'll take over the screen.
Yes, I'm so impressed with your team and everyone solving the questions and all those smart comments that everyone that participates contributed to the session. So I'm very happy, and I'm also impressed how you chose more of the harder questions than the easier ones, because I'm not sure if everyone knows Math Kangaroo questions are always, the competition is divided into 3 sections. The 10 questions are kind of easy, that most, not very easy, but kind of doable for an average student. The next 10 are a little more difficult, and the last 10 are the most difficult. So I feel like you had more questions from the second and third part of the competition. So it's amazing how well you did. And I just, I do remember Megan. Hi, Megan. She's very humble, but she's one of the top students, Math Kangaroo students. And I see her every year on the top 3 list. So she's amazing. And I'm glad to meet you in person finally.
Yeah, I've had so much fun here. You don't know this, I was actually talking with the coordinators on our end. This wasn't scheduled to exist. This second meeting where we get to show more of you through the contest you took, I was asking the people organizing it to set up a second time just so I could make it, because I love Math Kangaroo so much, honestly. Been doing it since a tiny child. I've gathered, like, literally, I had free time. I got not 1, but 2 Math Kangaroo plushies, and not 1, but 2 Math Kangaroo games, and this is like half of the Math Kangaroo stuff I have. Like, it's such great, so much fun. Not even an alumni, like, I still do it. I got into like a really great camp with them. Like, it's just so much fun. I'm so glad I could be here today.
Yes, that's a
be
great
among us.
surprise. Great surprise. I did not expect any of the hosts to be a Math Kangaroo participant, so it's a great surprise and honor to me as well.
Oh.
Yeah, so thank you everyone, Po-Shen, whatever you want to say. But again, I invite everyone to Math Kangaroo, and you can also, because the competition is once a year, so it looks like it's far away, all the way till March. There's nothing to do now, but there is a lot to do actually. There's a lot of problems, and I hope Po-Shen will do more sessions like that for students. So we'll have this great collaboration, and between now and next competition, there's many opportunities to practice Math Kangaroo questions.
Yeah. I say
Wonderful.
definitely do it, because like if you're scared of math, this is a great way to learn your math thinking without having to know so many of the like deep-seated tricks. Like nowhere in this competition did I have to use the choose function. But that doesn't mean it didn't stretch my mathematical problem-solving brain.
Yeah, these are amazing problems, honestly. I really enjoyed solving them. Especially the Battleship one. You actually only had to know how to... Actually, you didn't even know how to play Battleship. But if you did know, it was helpful. All right, y'all can let us know if y'all can connect any of the other problems to any games. That would be very cool.
Yes.
That's a good question.
Cool. Well, with that, I just want to say thank you to everyone. This was a lot of fun. So good night or good morning or good day. I think that's how they say it in Australia. If you liked this, we actually do these kinds of things quite a lot, and we are actually going to do more of these collaborations with Math Kangaroo. Just stay tuned. And also at the same time, if you like these kinds of live solves, you can always see on the various on the YouTube channel that we've been broadcasting all of this on. We're actually going to be starting very soon something where every single day we do one of these live solves. It'll be different from this actually. Those are where we ask you to ask us any question you want, and we attempt to solve them on the spot. We'll see. We'll see if we have the guts to do that. Well, the answer is we actually do have the guts to do that. We just have to set up the technology. However, stay tuned if you love Math Kangaroo, because the difference between those live Ask Math Anythings we're going to run and the ones that we do with Math Kangaroo are that the Math Kangaroo ones will have actual Math Kangaroo problems, which are very, very creative. So stay tuned for all of these things. With that, we wish all of you a good evening and take care. Bye-bye.
Yeah, thank you guys so much for coming. It was a lot of fun to have you all here.
Yeah, bye everyone.
Aiden, look what I grabbed.
Oh my god. You are... Oh my god, that's a lot of stuff. When have you been doing this?
Since first grade.
Dang, that's a long time.
Yep.